Hello and welcome to the Energy Resilience Lab. Our lab is dedicated to giving you the knowledge, skills, and the encouragement that you need to become energy resilient and energy independent. Today I'm jumping on to do the next step in the series. So we've already converted an RV from lead acid to a lithium-based 12-volt battery. And the next step to enhance your experience with off-grid storage system would be to add a inverter to your system. So to add the inverter, you need to decide how much power you need. Just in general, when you're looking at RVs, there's different levels. So the bottom level for like a camper that's in the back of a truck or an overlander would be 15 or 20 amps at 120 volts. And then the next kind of tongue pull trailer goes to 120 volts at 30 amps. And then when you get into large RVs, so the large trailers, they'll have a 50 amp 240 plug that powers their system. It usually jumps to that when the rig needs 2 air conditioners, so they can put an air conditioner on each leg. And then if you have more things like laundry machines and other heavy draws, they'll distribute that onto the 2 legs to get you enough power. And so the first job is for you to assess how much power that you need. You can derate it, so you could make your energy source system just cover certain things, like if you just want to run a microwave or the air conditioning independently but not both at the same time, then that's an option. And then that requirement would usually be about 2,000 watt inverter. So you need to find an inverter that is compatible with lithium batteries. So the charging and discharging range for lithium iron phosphate is going to range from about 10 volts up to the 14.6 at a maximum. And so you need to find an inverter that's capable of, if it's bidirectional, capable of charging the battery and discharging the battery to those levels. And then once you know kind of your power requirement, then you want to start looking into the energy that you need. So if you're just planning on popping popcorn or something, then you're going to need about 2,000 watts for a couple of minutes, which is a very low energy requirement. Or if you get into the air conditioning, then you're going to need a continuous 500 watts to 1,200 watts on the kind of mid-range where you're kind of a tongue pull trailer. So those are the max kind of the limits that you need to go through. And so once you determine that, you can size the system. So a 2,000 watt inverter at 12 volts is usually going to be taking around 150 amps. And so you need to confirm that your battery, if you just have one, is able to supply that many amps continuously. If not, then you need to augment it and add more batteries in parallel. And what that does is it allows the batteries to balance together and act together. So when you're drawing a lot of power from the system, the energy will be split between the 2 batteries, and it will be able to sustain that discharge for the time that you need. Usually when you get into the air conditioning side, you're going to be into a lot more batteries. So for every hour you want the air conditioning to run, I would say you need about one 100 amp hour 12 volt lithium battery. So once you have those parameters met, you can make the purchase, get the inverter, and then you can purchase more batteries if you just have one. So in the last video, we were talking about just changing out the lead acid battery and putting in the lithium battery. So you just have 1 or 2. But now once you get into the large stuff, you're going to want to add more batteries most likely, and maybe different charging methods to speed that up. So now that you know how much hardware you have, batteries and inverter, you need to decide how you're going to lay it out. So we'll usually co-locate all the batteries together, and you find the dimensions, whichever way you're stacking them, and you have to do a bus bar layout or a wiring layout. With this, it's usually recommended to get a bus bar and combine all of the batteries symmetrically to the bus bar. So what that means is the wire lengths from the inverter to the bus bar, they can be different lengths because they're the only things, they're the single track to the energy source. But if you are going from the bus bars to the batteries, now it matters how long those wire lengths are. And so you want to standardize that, make them exactly the same. And what that's going to do is it's going to maximize the possibility that your internal resistance of the batteries and wiring are at the same level. And that means that each battery will be loaded the same. So if you're discharging the system at full power for a long time, the energy of the batteries will extinguish at the same time. So some problems that you'll get into if you have an unbalanced system is that one battery will have to supply more amps than the other. And as soon as that turns off, the amps will then rush into the battery from the battery that wasn't discharged as much into the battery that was discharged more. And so what that is doing is it is short cycling your battery. So it's getting charged every time. Like if you use your microwave 50 times a day, you are allowing amps to backfill into that battery 50 times a day. With lithium iron phosphate, it is more tolerant because the voltage level is very flat between the batteries. And so if you're at approximately the same state of charge, within 20% or so, there shouldn't be as much inrush between them, but minimizing that is going to maximize the life of the system. The other concern is that when you're charging and discharging, it will tend to charge the battery that has the least resistance more quickly. That does remedy itself as you keep using the system because the internal resistance of the batteries will increase as it's cycled and aged. So in the process of it aging and becoming a mated pair of batteries, that will tend to level itself out. So that's less critical. So once you have that done, the next step would be looking into seeing if you want to do solar. And if you want to do solar, my recommendation would be going to a maximum power point tracker. And what that's going to do is going to maximize the amount of solar that enters the battery. So it matches the internal resistance of the solar to get maximum power transmission from the solar. And then it matches the internal resistance of the battery to get maximum current into the battery. And that gives you the optimum state and the optimum power transfer across the system. If you don't do that and you just do a pulse width modulated charger, all it's doing is short-circuiting the solar onto the battery at a very high frequency. It could be at megahertz or kilohertz. And that is going to try to it matches, so it brings the two internal resistances of the solar and the battery in line with each other, which is not maximally viable. So that is the concern with that. So I'd recommend you do a MPPT. So that gives you the system recommendation. So that's what I would recommend, is you just get the system with the maximum power point tracker and get an inverter that is big enough to power the loads that you need. And what you'll notice when we're going through these little descriptions is that it is the same for every system. So if you're trying to make a system in the back of your truck or an overlander or something, you can go through the same process of just defining how much power you're going to use, how long you want to use it, and then that will determine how much hardware you need to get. And then from there you mock up the volume and get that system installed into your RV. In this case, we're not using a transfer switch, so we're just using the connection from an inverter. So what you would be doing is, instead of having a system built in that auto transfers the power to the loads in the RV, you are going to manually do it. So you not unplug, but you get the cord out of your RV, wherever it comes out, wrap it around the RV and plug it into this energy storage system. So the most common place for that would be in the front bay, where the 12-volt batteries usually are in most RVs. So if you keep it there, that's going to be the most convenient option to do it. So thank you guys for getting on. Sorry this went a little long, but I'll just keep posting and helping you guys work through your process to get energy storage systems in your RVs and other toys, in addition to in your homes and businesses. So thank you guys. Please share this and get the